Okay, and let's continue on to section 1, Introduction to Application-Centric Infrastructure, ACI Fabric Components. As you can see on this slide, we have a spinal leaf ACI fabric. And as we mentioned on our previous video, we have our spine layer. So the spine layer, as we mentioned before, is aggregating all of our leaf traffic or our endpoint traffic. So anything that is connected on the leaf layer is going to be reflected via the spines to my destination leaf. So let me talk about the protocol that makes this magic happen, and it's COOP, and that is the Council of Oracle Protocol. And the Council of Oracle Protocol is a proprietary protocol that was designed for the ACI learning process, or I would say the ACI endpoint learning process. Let me explain. So let's say we have a machine here. So we got a server, and the server is plugged in on leaf 1. The MAC or the IP of this server, let's work on the IP. The IP is going to be 10.10.0.10. And let's say we got another server here, and this server will be on the same VLAN. Let's not change our broadcast, or let's not change our VLAN ID. We're just going to leave it in the same ID. And this server is going to be 10.10.0.20. Okay? So with the Council of Oracle Protocol, there is an information that is going to be exchanged between the spine and the leaf. And this information is going to be forwarded in a 0 message queue. 0 message queue. And what it does, in a nutshell, it's going, let me go ahead and delete real quick here, CMQ. What it's going to do is going to say, the leaf is going to announce via CMQ on Council of Oracle. So the protocol will basically grab the information in this transmission format. So I am going to send this IP, or let's say we have a MAC address that ends in AABB for this particular server, and we have another MAC address CCDD. So let's say the MAC address of this server ends in AABB, and the MAC address of the other server ends in CCDD. So CMQ sends the attribute in COOP, gets to the spine, and in the spine, I am going to have a COOP database that stores the information from this endpoint and then advertises the endpoint, all my destination leaves, not only the machine that I want to get to, also all the other leaves, because let's say I have another machine that wants to communicate to the machine that we're talking about, the .10. So we have another server here, and let's say that server is .30, and now that 30 wants to reach .10. So the leaf 3 will send the request back upstream to the spine, and in the spine COOP database, it's going to have an entry for this endpoint. And the endpoint and the spine basically is going to say, oh yeah, in my database, I do have the endpoint information. So let me forward it down onto my destination leaf. So think of it this way, COOP, let's say we have a highway. The highway is COP. We're going to do a very unique way of doing a vehicle. Right? Our vehicle is going to be CMQ. So we basically send our IP using CMQ. We send this information. Hey, I do know about 10.10.0.10 with CMQ. And this is how I learn MACs and IPs from my endpoints on my ACI fabric. This is the magic of ACI. It's happening at a layer 3 perspective because my underlay, as we mentioned before, is strictly layer 3. So all my fabric links or uplinks are layer 3. So this information is sent in a layer 3 fashion. This is happening across the board. So CMQ is advertising everything from a leaf. And let me give the pointer. So from a leaf to spine, I am actually informing all my endpoint information with CMQ. So once I have CMQ tells spine 1 and tells spine 2, I have an address learned over my leaf. So if anyone wants to reach this address, this is the path that I would take. I will go, if I am dual home, then I'm just going to go ACI spine 2, back down to leaf 1, or spine 1, back down to leaf 1. Both of them, they're going to have exactly the same database information from all my endpoints in the fabric. In this case, all my leaf are going to be advertising that information upstream to the spine. And then we have the APIC. And the APIC is the application policy infrastructure controller. And what it does, it's basically making the policies enforced on all my leaves. All my configuration, all my policies, all my objects, all my contracts, all my routing changes, all my tenants, all my endpoint groups. And again, we're going to go and discuss every single item. All that information that I configure for this fabric is going to be applied with the APIC. So the APIC is going to send the information to the adjacent leaves, which are going to be configured across the fabric. So the APIC is just going to send the information to all the leaves because I do my discovery. So the first time I boot up all my switches, the first time I take them out of the box, plug all in and plug the APIC starts learning all my switches, and it's using LLDP as the learning protocol to learn this information across my fabric. So I will learn about my spines, I will learn about my leaf, and basically when you see the new fabric, and we're going to go to the learning process so you can see it yourselves. The learning process, it's where you actually start commissioning those devices. And then you're going to see a model display for, say, for example, if this is a 9364 spine. So you're going to see that model and then you're going to commission it. You are going to name it the way you want to name it, or the naming convention that you want to apply. That's the moment when you do it during the commissioning process. So the APIC is basically making all the configurations across the board. So instead of me going to every single leaf, it's the orchestration, automation, it's the policy enforcement, it's the brain of ACI. So everything gets configured inside the APIC. Once I create a single object, this information is going to be sent to all my leaves. If I make a configuration that affects the spines, this information from the APIC is going to be applied to the spines. If I need to upgrade the firmware on my fabric, this is also pushed from the APIC. Very important. Per Cisco, it is mandatory to be in compliance, and in order for you to obtain hack assistance, if you open a attack case, you need to have a fully compliant fabric, and this means 3 ACI APICs. It is mandatory that you have 3 ACI APICs. And I would say, well, I have 2. 2 is redundant, and I think this is the reason why they want to do it, is they want redundancy, but why 3? Well, ask Cisco. But yes, you need to have 3. You need to have 3 APICs in order for you to be compliant. If you don't have 3 APICs, you can still run the fabric, but you're going to see a message on the GUI flashing saying that you're not compliant. And if you need to open an attack case, they're not going to support you unless you have 3 APICs. Okay? In the APIC side of things, all my APIC links are going to be connected to my access ports on the leaves, not the ALEs, the application leaf engine ports. Those are different, and we're going to discuss each one now. So all my APICs are going to have on the back of the APIC is basically a UCS server, a Cisco UCS server. I'm going to show a picture right now. You're going to see a virtual interface controller. So you're going to see a VIC, and then you connect one side of the VIC or one interface, one port of that VIC to one leaf, and then another port of the other VIC to the other leaf. So you have redundancy. So if you lose one leaf, you still have another leaf that you can communicate and still perform changes on the fabric. One APIC is active at a time. The other ones are just standby APICs. If I lose an APIC, the other one becomes active. So this guy is going to become active. If I lose this one, then finally this one becomes active. If this goes down and I lose all my APICs, will I lose whole fabric will stop working? No, it will not stop working because I have already the information configured on each leaf. You better make sure that you have a backup, because once you bring the APIC online, if the APIC for some reason has a catastrophic hardware failure, you might need to restore the whole fabric. So you might need to, rebuild the fabric. But in this case, if you have a backup config, you just upload the backup config and it's just going to auto configure itself and you should be good to go. But you got to make sure that obviously backups are very important. Okay, so let's go to the next slide. In this slide, you have some pictures of the actual ACI hardware. And we mentioned the application policy infrastructure controller. It is basically a Cisco C220, and you're going to see them in the M5 Factor, the M4s, etc. So this is the APIC M2. So you have a UCS C220. On the back, those are the interfaces that are going to be connected between two leaves. So you're going to have one leaf here, and then you're going to have another leaf here. And those are the interfaces that are connected to my fabric leaves. And again, if I lose this leaf for some reason, I can still communicate via 2. Okay, so we got the spines here. And the spines, they're advertising all my leaf information across my whole fabric. So like we saw on our previous slide, if I have a server connected to leaf 1, that information is going to be advertised using COOP or COOP, Council of Oracle Protocol, to the spines. And the spines are going to store that information on its COOP database. The spines are connecting the leaves to the application leaf engine ports. And this is basically a fancy name to call the leaf to spine uplink or connectivity. Those uplinks that you see color on your right side of the switch, those are interfaces that support MACsec. So if you want to encrypt that traffic between my leaves and my spines, and you have a requirement to do so, you can do with MACsec if you select those interfaces. Okay? If not, you can still use the regular label interfaces and you can still connect to the leaves. The Nexus 9364. This switch has a 40 and 100 gig multi-Ethernet speed interface. And this is a QSFP form factor interface. So you either use a directly attached cable or the DAC or DAC, or they also call them twin-ax, or you can use the QSFP with an LC fiber patch going to the leaves. I have a 9332, and it's basically a smaller form factor. This is a 64 port model. This is a 32 port model, and they basically have the same feature to encrypt using MACsec on those last 8 ports. So the ports that are on the far right of those spines are basically ports that allow encryption on your fabric. So they are going to encrypt that traffic, that underlay, or I would say that connectivity between the leaves and the spines are going to be encrypted if you use those ports and you obviously configure the MACsec feature. And finally, we have the leaf. And I would say the leaves are kind of the workhorses. They do all the magic in the fabric. They forward traffic, they encrypt traffic, they route traffic, they do everything. The leaves, in this case, there's 2 form factors. There is a chassis-based leaf, and this is a 9504 because we have 4 line cards available for port density. So we need port density, we keep adding line cards, and also if we need or different media factors, we just use a line card for that particular purpose. This is a rack mount 2U leaf where you have a fixed set of ports and you use those ports to connect all your devices to the fabric. At the end, we have the ALE, and those are the application leaf engine ports. And as we mentioned on the spine section, they connect to the spines, and back down, the spines connect to the leaves using the LAEs. In the leaf section, they're usually on the far right. You don't use a access port or an endpoint interface to connect to the spines. You use the last set of ports to perform that function. In a summary in this video, we talked about the APIC, and the APIC is where all my policies are going to be configured and are going to be pushed onto all my fabric devices, in this case, my leaves and my spines. The leaf, it encapsulates, it routes, and it enforces policies. It's basically running the show. They're in charge of running the whole fabric, routing, forwarding, encryption, encapsulation, you name it. They're basically the brains of the operation. The spines are reflecting, aggregating, and forwarding equally your traffic to your destination. So if I have, and let's draw a quick poor man's fabric. So if I have a simple 2-leaf, 1 spine, the spines are basically allowing traffic or reflecting the traffic to the leaves. So if I have a machine here, this machine wants to communicate to a machine here, they basically go via the spines because the spine is advertising the information for my destination. The spine are reflecting that information back down to the leaves. And we say that it's scalability because with the scalability that a spinal leaf topology offers, if I have a fabric that I need to expand because we're adding more servers, more storage, more access switches, we can definitely go ahead and add another spine, and we keep expanding our fabric left to right, right to left. It's east-west traffic flow, east-west expansion. So let's say we need to add 5 more leaves. Then we go ahead and do the 5 more leaves. 1, 2, 3, 4. And then let's say 1 more is 5. And then, you want to make sure that you have a more robust spine layer. Then you keep homing. Here. You see where I'm going. So you go and connect everything together. And that's what allows you to keep growing your fabric footprint. Okay, everyone, in our next video, we're going to take a look at policy-driven architectures. Thank you for watching.